Good morning students, welcome back to the session. Today we will learn about the Mason's gain formula. So my SJ Mason has introduced a method for finding out the transfer function of a control system if it is represented by a signal flow graph. So it is very easy to find the transfer function by this method. So he is SJ Mason who has introduced this method, and the formula introduced by him is called as Mason gain formula. It is named after him, Mason's gain formula. Let us see what is the method of Mason gain formula for making a transfer function. If a signal flow graph is given to you, then you can easily make into a transfer function, that signal flow graph. So we will see now what is the Mason gain formula. If RFS is the input of the control system, and if C of S is output of the system, then we can write transfer function as R of S by C of S, where the initial conditions are 0. So if transfer function is given like this, R of S by C of S, then we can find out this transfer function by using Mason gain formula also. As we have seen block diagram reduction technique, and also from signal flow graph we have got a transfer function, and now we will use this Mason gain formula. What is that Mason gain formula given? So if we want to write the Mason gain formula, then transfer function T, we denote it by T. T is equals to 1 by delta sigma k is equals to 1 to n pk delta k, where pk is called as forward path gain. Pk is called as forward path gain, and where k is the number of forward paths. K is number of forward paths. Here we need to find Pk as well as K. What is the number of forward paths we have to know, and also we have to know the forward path gain. So we can call it at this T as overall gain. In the Mason gain formula, the T is called as overall gain, and also we can call it as a transfer function also. So as we know, T is equals to T of S is equals to 1 by delta sigma k is equal to 1 to n pk delta k. Okay. This is your formula given there. Now we have to find out what is delta. Okay. If you find out delta, then we can easily get the Mason gain formula. Okay. We will see the Mason gain formula, what it is written. So we will see the Mason gain formula here. So delta is equal to, we will write here delta, what is delta, and we will find out what is the transfer function, or we can say as a overall gain. So we are writing here delta value. Delta is equals to 1 minus sum of individual loop gain, sum of individual loop gains plus sum of gain products, sum of the gain products of all possible of all possible combinations of two non-touching loops, combinations of two non-touching loops, minus sum of gain products of all possible combinations of three non-touching loops, plus dash dash dash. That means that if you want to find this transfer function here, Mason gain formula, here you are having 1 by delta, you have to find out first 1 by delta and later you have to do the summation of pk into delta k. So for that you have to know what is a non-touching loop. If a signal flow graph is given to you, then you have to easily find out the non-touching loop as well as the sum of the gain products. Sum of the gain products you have to know of all possible combinations of two non-touching loops. If there are two non-touching loops, then you have to find out the sum of the gain products of all possible combinations. And here also it is a plus symbol, and again you are having a negative symbol. Again you have a plus symbol for even and negative symbol for odd. So you can see this formula delta. If you are able to find delta, you can easily find out the transfer function of the system. And also we write here delta k is equals to delta k is there. Delta k is equal to delta for that part which is not touching kth forward path, forward path. Okay. So we have a signal flow graph now, and if by signal flow graph you can deduce this transfer function, you will see it. Okay. So students, if the video is given in the video, we will see that find the overall gain C of S by R of S for signal flow graph shown in the figure. So if you see this signal flow graph, the signal flow graph will be given in this way. If you see this signal flow graph, it is having R of S and C of S, and afterwards you are having this gains G1, G2, G3, G4, G5, G6, and here minus H2 and minus H3. You can observe here that there are some reverse paths also. You can see the arrows here which are not in the forward direction. So what we do here is first we will find out the forward paths. First we will find out the forward path from the signal flow graph. So begin from the forward path. So how many forward paths you will see in this figure? You are seeing this one is a forward path from 1, 2, this 3. So G1, G2, G3 and G4. These are the forward paths. And one more forward path also exists here, G1, G2 and this arrow mark. Here it is having from G6. So this is also one forward path. The forward path means where the direction will be in the forward direction, in the forward path only. So the path doesn't have any reverse path. It doesn't have any reverse like you are seeing here, it is minus H3. So it will cannot come back like this. The forward path means only in a forward direction. So we will see how many forward paths are there. So for forward path 1, we will write that C of S and R of S. So it is 1, 2, 3, 4 and 5 here. It is C of S. Okay. This is one forward path which is having G1, G2, G3, G4. Now we can find out the gain of this forward path. We can first find out the gain of the forward path, and we can find out the number of forward paths also we can find. Okay. we can write here what is the gain of the forward path 1. So, gain of the forward path 1 is like gain of forward path 1 is given by P is equals to G1, G2, G3 and G4. G1, G2, G3 and G4. Product G2, G3 and G4. In the similar way, other forward path is also there. This is step 1 of finding the forward paths, and this is second step for finding the other forward path. Now we will see the other forward path here, that is G1, G2. So it is we had note the points, also note points, and here it is this point G6. G6 is also a forward path. So it is at 2 only. So it is 2, G1, G2, and it is starting from here. So you will have here one more forward path is G6. Okay. See here this G1, G2, and these are the points 2 here, and this is the third point, third node you can say 1, 2 and 3, and from here it is having a forward path up to C of S, that is C of S, and here it is R of S. So if you see this one, then you will can write the gain of the forward path 2. Gain of the forward path 2 is P is equals to G1, G2 and G6. G1, G2 and G6. So already we have written path 1. Again we need not write this G3 here. So G1, G2, G3, G4 is the first forward path, and second forward path is only G1, G2 and G6. We don't say here it is a forward path here because it is having the reverse one minus H2 here. So don't consider as a forward path. So G1, G2 and G6 is one forward path given by P is equal to G1, G2, G6, and first forward path is P is equal to G1, G2, G3 and G4. So what is the next step? Next step what you have to do? So if you see this second step now, the second step is finding the individual loop gain. First step we have completed. Now we are doing the second step, that is individual loop gain. How to find out the individual loop gain of this? So first see this first diagram. If you see this here, you are having 2 and 4. 2 and 4. In between 2 and 4 you are having this loop 2 to 4, and again from 4 to 2 you are having one loop. So the gain also given here minus H1, and here the gains from 2 to 3 are G here is given, and also from here from 3 to 4 also it is the gain is given to you. So if you are having these particular gains given, then you can easily write down the formula for loop gain. So if you see here the loop gain formula of the individual loop 1. Individual loop 1 means this is the individual loop you are taking from the signal flow graph, and the individual loop gain is given by P11. P11 is equals to minus G2, G3, H1. Why? Because it is the first loop gain. First loop gain P11. It is given as minus G2, G3, H1. Why you are taking minus sign here means it is due to the minus H1. You are getting a minus sign here. So the individual loop gain of this particular loop 1 is given as P11 is equals to G2, G3 into minus H1. So the product comes here minus G2, G3, H1. Now we will go for the loop 2 now. If you see here loop 2, there are totally 5 individual loops in this particular signal flow graph. If you observe, you are having 5 individual loops. So we will go for the second loop now. If you are seeing here second loop, we are having 2, 3, and this is minus H2. This is also a loop. No, loop means where it is starting, it should be ending at the same place. So it is ending at the same node, that is 2. So if you see this second loop from 2, 3, and the gains are G2 and minus H2, the loop gain is nothing but the product of that one. P2 is equals to minus G2 into H2. Minus G2 into H2, that will be the second individual loop gain. So individual loop gain is given by minus G2 H2, but the negative sign comes from this negative minus H2 value. And what is the third loop? So if you come here, the third loop is given like you are having from 2 to a junction point here. You can see 2 junction point where from the 2 you are having number of this particular loop gains G2, G6 minus H3, G2, this is G6 and minus H3. G2, G6 and minus H3 means it is forming one loop. So if you see here, the directions are coming 2 to 5, this is a forward, again from 5 it is reverse up to 2. So we can write the this particular loop gain as P31 is equals to minus G2 G6 into H3, minus G2 G6 into H3. Negative signs come from this negative value of H3. Okay, so just you are writing the loop gain formula for loop 3 also. After completing this loop 3 loop gain formula, then we are writing the loop 4. Going for loop 4, you are having 2, 3, 4, 5 nodes here. 2, 3, 4 and 5 nodes. In between that, we are forming a loop here. G2, G3, G4 are the gains, and minus H3 you are also having this minus H3 negative sign. So up to 2 it is being shown. So we are noting that this individual loop and forming the loop gain of the individual loop 4. So this is loop 4. If you find that one, you will get P41 is equals to minus G2 G3 G4 minus G2 G3 G4 into H3. The negative sign comes only from this minus H3 only. So you can write negative here, G2 G3 G4 and H3. And the last loop is the individual loop is fifth loop, that is P51, where it is having here. So you can see that it is again P51. You can write P51, that is equal to G5, that is equals to G5, because here the gain is a small gain here, G5. Loop gain, individual loop gain of loop 5 is given by G5. So we have got here 5 individual loop gains. After finding out the individual loop gains, we will move to the next step now. As we know how to find out the third step, that is the gain product of two non-touching loops. The gain product of two non-touching loops means you are having here two non-touching loops in this particular signal flow graph. So non-touching loops which does not touch the more than one. So if you see here 2, 3 and minus H2, 2, 3 and this is a non-touching one. So combination of these two, combination of two non-touching loops we have to find out. So first combination is this 2, 3 H2 and G5. So these are non-touching. So this is separate and this is separate. These two loops are non-touching loops. We call it this loop as well as this loop as two non-touching loops. So we find here the first combination. This is the first combination of two non-touching loops. Now we will come to the second combination. Second combination is given here, that if it is a non-touching loop, which one? You will see here G2 and G6 and this 2, G2, G6 and minus H3 up to 2 here, and this one and this particular same G5, these are non-touching. If you see this loop, G2, G6 and H3, G2, 2, 3 and this one, this particular one. I have drawn this for simplicity, I have drawn here. You can see that 2, 3 and 5 nodes are there, and here you are having that particular loop which is non-touching to G5. So these two loops are non-touching. So we find the non-touching loops means we don't have the contact between this loop as well as this loop. So this is second combination, this is first combination. So these are two non-touching loops. In the signal flow graph, we have two non-touching loops. So first combination is given here and second combination is given here. So we will find the now this particular gain. Gain is find out like this, P21 into P51, so gain product, minus G2 G5, minus G2 G5 H2. How did we get minus G2 G5 H2? Means G2 H2 is the gain of this particular loop, and we are having G5 as the loop gain of this particular loop. We are making the product minus G2 H2 and G5, minus G2 H2 because it is minus H2 is involved in this case. And here we have this G2, G6 and minus H3, G2, G6 and minus H3 we have written one loop, and again G5 is another loop here. So the product of these two loops we are writing the gain product of two non-touching loops. So first step we have find out the forward paths, number of forward paths there, and the second step also we have done by finding out the individual gains, and the third step here is finding the gain product. Okay, now you will go to the fourth step. So students, this is the fourth step here. Fourth step we can see calculation of delta and delta K. After that we are having one more step, that is the fifth step. first we have to find out delta and delta k. How to find out the delta? As you have written the formula before only, what is delta formula. Now we will be writing this particular sum of the loops, individual loops, two non-touching loops, and again we are writing here this plus sign. Like that we will be having that formula. So if you write this 1 minus delta and delta k, if you see here, delta is equal to 1 minus P11 plus P21 plus P31 plus P41 plus P51. So these are all the individual loops. So these are all the individual loops here. So if you see here, P11, what is the value of P11? Already you have written minus G2 G3 H1, minus G2 G3 H1, and P21 is minus G2 H2, and P31 is G2. This is P11, P21, P31, P41 and P51. So we are writing this particular formulas here. So we are having here total 5 gains. Minus G2 G3 H1 and P21 is minus G2 into H2. Whatever we have written previously are again written here now. So P3 is minus G2 G3 G4 H3. P41 is minus G2 G6 H3. And we are having P51 as G5, the last loop what we have already seen now. And after that, what we are doing here is you are keeping a plus symbol, and you are doing the same thing again for 3 individual loops. Okay. So G2, G5 and H2. So here we write that this is the 1 minus sum of the gain products of all combinations of 2 non-touching loops. So and plus sum of the gain products of all combinations of the 3 non-touching loops. So these are the P12 and P22, and here it is all the combinations of 2 non-touching loops. The gain products are given here, P11, P21, P31 and up to 51. So here there are 5, and these are only 2 here. So we will write those gains, and we will get delta is equal to 1 plus G2 G3 H1 plus G2 H2 plus G2 G3 G4 H3 plus G2 G6 H3 minus G5 and so on. What are the values that are given here that are to be written like that. Now we will come to the second sequence here. Delta k we should find out. So k is equal to 2. Why? Because we are having only 2 forward paths there. We have seen the forward paths in the first step. So there are we can see that since there is no part of the graph which is non-touching forward path. So we can see that there is no path existing here which is a non-touching forward path. In forward path 1, if you see forward path 1 here, as we have drawn already, this forward path doesn't have any non-touching forward path. So there doesn't exist any non-touching forward path here. And if you go to the second forward path, there is so we can write here delta 1. Delta 1 is equals to 1 minus 0. So there is no non-touching forward path here. No non-touching forward path exists in this particular first forward path 1. First forward path 1 means 1, 2, 3, 4 and 5. Here there is no part of graph which is non-touching. All are touching here 1, 2, 3, 4, 5. And if you come to the second forward path was like this, G6. And here if you see in this particular forward path, there up to from 1 to this 5, you are having one non-touching forward path. There was one non-touching forward path, that is called G5. So we can write the formula here, delta 2 is equals to 1 minus G5. As in this forward path from 1 to 5, first forward path did not have any non-touching one, and because here G4 also touch, this was also touching there, so we wrote 1 minus 0. Now second forward path, if you see this particular forward path 1, 2, 3 and this 5, 3 to 5, non-touching, this is non-touching. So in this forward path this is non-touching, and therefore you have what you have done is you have done 1 minus G5, this loop gain 1 minus G5. So delta 1 and delta 2 is equals to delta 1 is already here 1 and delta 2 is equals to 1 minus G5. Now we will go for the fifth step of writing the transfer function. So students, now the fifth step is your forward the transfer function, how to find out the transfer function. So if you see the transfer function, you have to see the formula T is equals to 1 by delta sigma k is equal to 1 to n pk delta k, and where k, this number of forward path is 2 only. Here, as we have seen in the first step, we have find out the number of forward paths, and in the second step we have find out the individual, first we have found out the forward paths and we have find out the forward path gain. Next, what we have done here is we had find out the individual loop gain in the second step. Okay, and third step we have find out the non-touching loops, the gain of the product of the gain product of the two non-touching loops we have found, and in the fourth step we have find delta as well as delta k. After finding out delta and delta k, now we are writing the fifth step as a transfer function. So it already 4 steps have completed now. So 4 steps was, first one was forward path gain. In the first step we have seen that there are number of forward paths are 2. So we write k is equals to 2 here. K is equals to only 2 because 2 forward paths are there. Now we can write here this summation can be written as T is equals to P1 delta 1 plus P2 delta 2 because there were 2 forward paths, and by delta, because 1 by delta is there, you can write here 1 by delta. So if you write this complete transfer function, then you will be writing this transfer function as P1 into delta 1. What we have got, delta 1, the values of delta 1 and the values of delta 2 are being written here. So you can see here delta 1 was 1, as we didn't have that 2 non-touching loops. Fourth point, in that we have seen we got the value of delta 1 as 1, and here we got the delta 2 as 1 minus g5. 1 minus g5 was the delta 2 value, and P1 and P2 already we know P1 and P2. From this P1 and P2 we can now write this complete transfer function. So this transfer function has g1, g2, g3, g4 into 1 plus g1, g2, g6 into 1 minus g5, that is delta 2 and delta 1 multiplied with P1 delta 1 and plus, here plus is there because we are summing here, and P2 divided by delta. What is delta? We have written the formula for it, like we have written the sum of 1 minus sum of the non-touching, the gain product of the non-touching loops, plus we have so on, we have written that delta value. So we whatever we have got the delta value, we are writing here carefully, we are writing all the steps here. After writing all these steps, we get this particular transfer function for the respective signal flow graph given. So in this way, Masson gain formula was useful for us for deriving the transfer function. This transfer function was derived by using these 5 steps only. So the block diagram reduction technique was applied, and also signal flow graph was also applied for deriving the transfer function. Now we have seen this method of Masson gain formula, where if the signal flow graph is given as a representation of a control system, then we can derive the transfer function in these 5 steps. Okay, we conclude our class here, students. Thank you, and we will be dealing about the next things in the next chapter. Okay, thank you.